First, I would really like to thank ABANA because they are sponsoring these educational webinar workshops. Let me just go over what we're going to cover today. The module number 1 will be the rationale of method. Module number 2 will be drifts. Module number 3 will be angled pass-throughs. Module number 4 is going to be all about diamond-shaped holes. Let's move on. I'm going to hand the floor over to Mark Aspery. Hi, Mark. Bring it on in.
Okay, then let's see if we can. So let's have a look at the first premise. If I take a normal blacksmith's round punch, let's say 1/2 inch in this case, and I put a 1/2 inch diameter hole in 1.25 wide bar, then aside from a little swelling at the sides, I get a nice round hole. Well, no problems with that. But if I try and put the same hole into a smaller bar, here I'm trying to put a 1/2 inch hole into a 1/2 inch bar, then I start to run into some problems. I'm just going to cut the bar in half. So what we're looking at is a way to get those larger holes into a smaller bar. And then for me, it enters the slot punch. I'm going to make a difference between the slot punch and the slitting chisel. So I am a slot puncher. I don't very often slit, and I've got some slides a little later on that show the results that I get when I compare the two, and hopefully that will be to your edification. In this one you can see that I've got at the bottom right the start of the slot punch, the middle hole is the slot punch as it's been punched, and then finally it has been drifted and I've got a 1/2 inch bar in a 1/2 inch hole with plenty of sidewall, and that's important to me. So I'm going to look at a few holes over the course of this presentation and next week as well, and I'll take questions as they come up if we can. Again, I can see the names here and I can see we've got some professional smiths, so just enter your questions down and I'll try and get to them as soon as I can. The problem with slot punching is it tends to be bar specific. If I start to do it into plate, typically what happens is I can make the hole no problem, and then when I drift the hole and make it round, it just pushes the material away from the slot punched hole, and I end up with that dam basically where the material moving is hitting the resistance of the other material, and I just end up with this, like I say, this wall. And of course then you come along with your hammer, tap that down, and you're back to being a slot punch again, and then you redrift and you get the wall, slot punch, wall, etc. And so I would say the slot punch is not really appropriate for the plate. If you want a hole in plate, I would either use again the 1/2 inch blacksmith's punch, or I would cut the hole out with a circular or curved hop punch. So this is me just doing a little punch here. I'm using a slot punch. I've got a piece of 1/2 inch square bar, and I'd like 2 1/2 inch round holes in the bar. You can see I've got some center punch marks in the bar. I've lifted the punch. You saw that dropped into the center punch. Bang. Look at the hole. Is that where you want it to be? And if it is, again, click, stand it up, hit it, look at it. If it's where you want it to be, then carry on. I always like to use tongs when I'm dealing with drifts. And that's a simple punch and drift method. For me, there are 3 main methods that we can use. We can punch and immediately drift, and that's what we just did in that little video clip. And I'm going to suggest the hammerhead would be one way of dealing with that as well. If you need a little more material around your hole, or if your hole's got some corners, for example, square rectangular blocking, then you can punch long, then upset, and then drift. So now you put some material into the area surrounding the hole. So then we come to the third method. We're going to upset the bar prior to punching, then we'll punch, and then we'll drift. So I'm just going to give you a minute to take your poll, and then if we've got any of the questions there.
Mark, Kirk actually asked a question. Are your drifts generally mild steel or carbon?
My drifts are a higher carbon steel because I want to rely on their resilience at heat. Now, they're not hardened and tempered. They're just made from a higher carbon or a higher form of alloy, for example, a 4140. So if we know that the round bar is going to be damaged by the punch, that little tap with the hammer that I just gave it is going to happen anyway. So why not tap it with the hammer and give yourself a little landmark that you can place the punch on? Actually going to drift this with a diamond shaped drift. So I'm going to try and open the hole as much as I can with the drift. Get it started, then I can capture my bolster, move the bolster in place, and then I'm going to drift. So drifts are like dinosaurs to me, typically. So dinosaurs, thin at one end, much thicker in the middle, thin again at the other end. Okay, yeah, thank you, Monty Python. So the size and shape of the working end of the drift has to reflect the size and shape of the hole that you will intend to redrift, that you intend to resize or shape. So if you've punched a round hole with your blacksmith's round punch, then the drift should be round, so it fits into that hole. If you punched a slot punched hole, then the end of the drift, the working end of the drift, should be somewhat slot punched shape, so that it goes in and is working on the hole of the slot punch. So for me, I like to think of the drift again in three parts. I have the main body, I have the struck end, and I have the taper to the working end. This is all very fancy, Victoria. You've done a great job here. I like it.
Thank you. Mark, do you want to show your face?
Sure. Okay.
Great. We've got one question that came in, Mark.
Okay. Yes, I do. Do I have a standard set of punches? I wouldn't say it's a standard set, but my slot punches go up typically in 1/8 of an inch increments. Angle pass-throughs. So this is the real benefit to punching from both sides. If we punch from both sides of the bar, penny on a penny, then we get a perpendicular pass-through. If we miss, as in the left-hand slide there, then we get nothing at all. But if we can overlap those two sufficiently, and I'll try and give you some rationale to this, then we can start to get a pass-through. Okay, that's a good result. Okay, so 73% have not tried angle pass-throughs. Okay, then I'm going to slow down a little bit here and try and get this for you, because this is important. But if we get that shared common slot right, then we can drift the common slot and fill the whole of the top of the A and B there, and we can get a nice angular pass-through. If you want to make a bolster, you can consider welding on some tabs to capture your material, and if you're slightly off, this will help recenter the eye in the material. Diamond-shaped holes. Again, these are quite nice if you want to pass a piece of bar through a bar on the diamond. These also come into play a little later on when we start to look at angle pass-throughs of these. I've said that the slot punch should reflect the size and the shape of the bar that you intend to drift to. So again, I need to start off with a drill hole in here, so I start off exactly the same way, 2-inch square bar. I drill a round hole, 7/16, then I could just resize it and reshape it to accommodate my needs. So in this case, I punched long, I had that 3/4 inch slot punch. I've got my angle drift there, and we're going to talk about that because that's a little fussy. And I've got my bolster plate, so I start my drift, I work from both sides, and I'm basically trying to keep the material centered in the bar. If I just start drifting from one side, I'm going to push some of the drifted bar into the bolster plate, and then I'll end up with flashing. So I hit it, looked at it, is that where you want it to be? In this case it must have been. Cool the tool, get rid of the water, and punch from the other side. Then I'm going to capture the bolster, and away I go. Give it a couple of taps. and dress the edges. Now in this particular case, I want to do a pass-through through that bar that we made in the video. I can't make that punch first. I've got to do the pass-through first and then punch. So I'm going to punch, check it, is that where I want it to be? And I hate punching across the bar like this. I'd much rather punch along the bar, but in this case, needs must. I'm going to bend this and we are going to protect that second hole as we punched it. Sounds like the volume's up a little bit. So I've got a spacer in. I could have taken the heat out of the hole, would have been even better at this stage.
That about wraps it up for the whole workshop, modules 1 through 4. If anybody has any other questions, now is the time to ask them. Thanks everybody for coming.
Yes, it's very nice, and thank you to ABANA for sponsoring this. This is cutting edge stuff for us. This is new ground, and I'm glad to see that ABANA is supporting that as we go forwards. They've done a great job. I'll be doing this as a workshop in the upcoming Salt Lake City conference in the educational area. So if this is something you want to have a go at, hands-on, etc., then we can do that there. Bruce, I've got your question. So do I upset for the angle pass-through in square stock? And yes, I do. Again, any time that the bar is not going to be supported, and typically as soon as you move away from flat bar, so you're in round or you're punching across the corners, the punch is not supported, and if I don't want to see that wasting, that drawing down of material, then I'll upset the bar prior to punching. So yes, good question. Thanks, mate.
Thanks for staying for the whole time, and I really hope that you guys got a lot out of this. It is kind of fun. I really like this little virtual classroom.
Yeah, I think this is the first time that this has been done in a blacksmithing model, and I'm really excited to have participated. Very nice. I like the videos. Great buffering. So whatever you did to the videos was excellent.
Good. May the forge be with you, everybody. Thanks so much. Good night.